As you learn more about C# and how it works, it's really important to visually see the code running and executing, as well as being able to confirm or test our assertions of what we feel is right in code. In this lesson, we will learn how to use a very powerful tool inside of Visual Studio called the debugger. Using a debugger is called debugging. You will often hear developers talk about debugging code. The term is used in two ways. First, the literal way, meaning you are actually using a debugging tool to help you debug the code. Secondly, the general term used by developers, saying they are debugging code, simply meaning they are investigating a problem in code or testing code out. Developers tend to use the term debugging whether they are using a debugger or not. For example, checking a website for bugs, running your application through a set of conditions that a user has reported a problem with, and investigating the problem in general. Finding bugs does not always involve attaching a debugger, so the term debugging code is generally used in both ways. The debugger in Visual Studio is very powerful, if not the most powerful debugger I know, and learning to use it efficiently will set you apart from other developers. Let's write some simple code that has an intricate issue, and use the debugger to help assist us finding and fixing the problem. Let me write a quick bit of code. What do you think the output of this code will be? Will it crash the console due to dividing by 0? Will the answer be 0? Or will it be something else? Let's run the code and see the issue we're faced with. And as you can see here, the output is 8. I bet you didn't have that as one of the expected results. So we need to debug this code to find out what's wrong. Without a debugger, this simple issue would be very hard to find for most people. The debugger allows us to see what each value is, line by line, and then narrow down where the issue lies. When you press F5, you are running this debug menu item. Start debugging. Visual Studio compiles the code, runs the application, and then attaches another program called the debugger into the running application's memory. It then inspects the running code, controls the execution flow of the application, and can inspect and manipulate the memory. For now, it's good enough to know that pressing F5 allows us to inspect, pause, run, and even edit our application live and see the results. It is incredibly powerful. Let's use the debugger to solve our problem. Start by clicking the grey bar to the left of the line numbers. This adds a red dot and highlights the line of code in red. In fact, the first line of code that executes in our application is not this line, it is the opening braces above. Let's click on the grey bar here to add what is called a breakpoint, which is what this red dot is, to the line above, and we will click the red dot below to remove the breakpoint from the line below. Now press F5 to run the application. Notice how this time focus is brought back to Visual Studio, and the line we had the breakpoint on is highlighted yellow. This means this is the next line of code to be executed by our application once we step over this line. While it is yellow, the application is not running. It is paused, and all its memory is viewable, and we can investigate what we like in the application while it is paused. See the yellow arrow in the red dot over to the left. This shows the line of code in the application that is about to be run. This line of code has not yet been executed. This is an important thing to note. The line that is yellow is about to be run, but has not yet been run. Remember in the beginning when I mentioned the application is run line by line, from the first line of code entering the block of main, to the end, and sequentially. Well, now you can see this happening. This is your proof of knowledge and learning. It is incredibly important to prove your assertions when learning code. If I tell you that code executes line by line, top to bottom, inside the main function of your application, then you want to prove it to yourself. Don't just take it as gospel, as indeed there are instances where this is not true. Now we are debugging our application. You can officially say that you are debugging code. So how do we progress and let the program run to the next line of code? We can press F10, or we can go to Debug and step over. You can see now the breakpoint above has turned back to red, which simply indicates it is a breakpoint that when hit will stop our code. But the next line in yellow is console.writeLine. If we take a look at the console window, we can see nothing has been output because this line has yet to be run. Pressing F10 to step over the line, we can now go back to the console and see that that line of code has now been executed and the words "Hello World" have been printed. Remember when pressing F10 to make sure Visual Studio is in focus to capture the key press. To inspect variables, hover your mouse over them. Notice how A is currently 0. That's because, as mentioned in previous lessons, each type has its own default value before we assign it a value. In the case of all numbers, the default value is 0. If we want to inspect a variable as we are stepping over code, without having to hover over them every time, we can right-click on the variable and click Add Watch. You can see down here now in the watch window, we have the variable name A and the value 0. This window will stay active and up to date as we step through code, meaning we won't have to hover over A to check its value every time we press F10. Now let's press F10 again to execute this line of code and step to the next. Or alternatively, you can hover over any line of code and click this button, the little green play button. So if we were to press the run button here, it would execute this line of code, as well as this line of code, and break on this line of code. So you can think of it as a run application 2, meaning if we started at the top and we hovered over this bottom line and clicked play, it would run all of these code lines and break here. It's up to you your preference when stepping through code. I wouldn't recommend using the menu to step over because it's long-winded. I typically press F10 to jump to the next line and step line by line. Or if you know you want to run to a certain point, you can hover over and click this button. For now, I'm going to press F10 to run one more line of code. Now that this line assigning the value 1 to A has been run, you can notice the watch window has updated the variable A with a new value 1, and it's also highlighted the value in red. This indicates since the last step in code, the value has changed. So since the last time this window was evaluated, the number has changed. Press F10 again, and you can see this number has gone back to white, indicating that there was no change since the last time we stepped over code. Let's press F10 once more to execute this result and find out what the answer is. We could hover over the result variable to see the value, or we could right-click and add to watch. However, you can also use the locals window down here. This is like the watch window, but it automatically includes all the variables contained in the current code block, in this case inside of our main application, plus any variables available in this scope. If we go to the locals window, we can see we have the args coming from the mains parameters. We have the A and B variables, and we also have the result, which you can see now is infinity. So our code did not crash dividing by 0. This is because floating point numbers, unlike integers, are capable of representing both positive and negative infinity. So far so good. Our code is behaving as expected. 1 divided by 0 is indeed infinity. This issue then must lie with the console.writeLine call. What happens inside the write line code can be found on GitHub, as .NET Core is open source, or we can see the source code by using tools like ReSharper. I rarely install extra tools in Visual Studio as it slows down the IDE, as well as introduce bugs into your executing code and your environment. I have seen this happen many times, and it's still the same today, so I do not recommend adding additional tools to Visual Studio unless absolutely necessary. We can look up the source code on GitHub by going to Google and typing .NET Core GitHub followed by the code that you are trying to find, such as console.writeline. This is typically the quickest way to find it. Otherwise, you can go to github.com/.net and then search for the code inside there. Instead of going down that rabbit hole first, I will share with you some knowledge I have that you don't yet to help solve this problem. When we pass in console.writeline, a variable, the console is expecting a string, text to write to the screen, not a number. However, if we stop this code for a moment and check out the possible options to pass in, we can pass in a string as expected, or we can pass booleans, characters, character arrays, decimals, doubles, floats, ints, longs, many other types. We haven't yet covered this in C#, but almost every variable, object and type can call .toString. You will learn this in future lessons, but all that is happening inside of writeline when a non-string value is passed in is it's calling .toString on the object passed in. So this console.writeline is equivalent to doing result.toString. Let's run the code now and see if we get the same result. And you can see we do. It still prints the number 8. To help narrow down this issue, let's move this code, the converting of the double to a string, into another variable of string, and then pass that into console.writeline. The reason for this is so that we can inspect this variable now and see what the result is before it goes into writeline to see if the issue is the result.toString call. Let's remove the breakpoint from the top, add a breakpoint to just below the execution of result string, and press F5 to run the code. If we now inspect the locals window, we can see the result string is actually showing this infinity symbol. That means we are telling the console to write the string infinity. But when we do this, it outputs the number 8. As we can see in the locals window, the result is an infinity symbol. So the conversion and therefore the variable passed into writeline is all correct and as we expect. That means the bug is somehow in console.writeline in how it chooses to write the string to the console, or it is in the console window itself trying to display the string. At this point, without the knowledge I already have, we may have to dig into source code of writeline to investigate further. However, I happen to know that the default character encoding, something we will discuss in future lessons, of the console is called code page 850. And this has no symbol for infinity. Code page 850 is basically an MS-DOS character map for all characters that could be displayed in the original MS-DOS. This is still present even in Windows 10 today. Back then, a symbol for infinity was not part of this character map. As I mentioned before, don't take my word for it, let's check it out. Press F5 to run the code. Go back to the console window, click the top left, then Properties, and we can see here, current code page is 850. A quick Google of code page 850 shows us a bunch of additional symbols here that can be represented, none of which are an infinity symbol, as well as it mentions on top of these additional symbols, code page 850 has all the code page of 437, which means it can also display all of these symbols, which is your alphanumerics, your standard symbols, your multiplies, times, divide, some math symbols and some bars. However, the problem is code page 850 cannot represent the infinity symbol. We can also check the output encoding of the console from code. To do this, I will use a special keyword called var for now. We will learn about this in a future lesson. And we will simply read the value of the console.output encoding. If we press F5 to run the application, and we can either hover over encoding to see the result, or we can look in the locals window. You can see encoding says system.text.os encoding. Clicking this arrow here expands the properties of the OS encoding, and we can see code page 850. So what is happening in code is when we tell console.writeLine to write a string that contains characters that are not representable by the output encoding of console, it has some logic to convert some specific symbols, in this case the infinity symbol, to the number 8. This is in the source code of WriteLine, deep inside the source code. The important thing is we have discovered where the issue is, and we would know where to look further. We have nailed down the issue to the console.writeLine call specifically by checking the result string before it goes into the method and knowing that everything up until that point is correct. This is the process of elimination, and this is a good way to solve problems. To fix this problem then, we can actually change the output encoding. If we hover over output encoding, you can see it mentions get or set encoding for the user. So, to attempt to fix this, we will write console.output encoding equals, and if we go to system.text.encoding, you can see we have some options. All these encoding methods you will learn about in future lessons. For now, we will use UTF-8. This is the most common Unicode format for text. This is the format used in JavaScript, in web files, in HTML, and most of the web. You can look up UTF-8 on Google if you would like to read more, but for now this is outside the scope of this lesson. If we put a breakpoint here and a breakpoint here, I'm going to show you a few more things with the debugger. Press F5 to run the code, and you can see we hit the breakpoint as expected. You can press F10 to step over to the next line. But what if we now want to just continue execution of our program until we hit the next breakpoint? Meaning we wanted to stop at this first line, we wanted to stop at this line here. We don't necessarily care now about stopping between these 2 points. Yet pressing F10, as you have seen, steps line by line and does not let your program continue to execute. So in order to continue to execute, you can go to debug and continue, or as you can see, you can just press F5 again. So if we press F5, our code will now run until it hits the next breakpoint, in this case, output encoding here. So let's press F5, and you can see it's now executed all of these lines of code and then stopped here. If we hover over console.output encoding, it is currently text OS encoding, which if we expand, is currently code page 850. We press F10 to step over that line, hover over output encoding again, and we can see that it has now successfully changed to encoding UTF-8, which is code page 65001. We can see the result string is the correct infinity symbol, and if we press F5 again to run the program to completion, we can check the console window, and now you can see it's correctly output the infinity symbol. This is because the infinity symbol is part of the UTF-8 character set. To fix this problem required a lot of knowledge that I have in a lot of areas. But this lesson isn't about you understanding and fixing the specific issue. It is to see and learn how to use the debugger to help assist you in finding where the issue is. In this lesson, you have seen how to run the debugger with F5, how to set breakpoints by clicking in the grey bar, how to step over code with F10, and how to inspect variables using the locals window or right-clicking on a variable and clicking Add Watch, and then looking at the watch window. There are many more things that you can do with the debugger, and this is just the tip of the iceberg. You will learn them all in future lessons. The debugger is very powerful in not only debugging problems, but helping you to learn, understand, and verify your assertions of code.